But I do apologize if I hurt your feelings. All right, here we go. Open up your homework to the section that talks about more challenging transformations. More challenging transformations.
Oh, how much time?
What we did in our checkpoint, what we did on Friday, that should secure your skill. Now we're going to try ones that are slightly more difficult. And for this first one, we are looking at a parent function of 1 over x. Do you remember what the parent function of 1 over x looks like?
No, I'm going to find it though.
It looks like this. It's a reciprocal function that has horizontal and vertical asymptotes. Okay? So I want you to look at a couple that are reciprocal functions. This first one and this sixth one here. Okay. Now this plus 2 is either on the inside or the outside, and this plus 3 is either on the inside or outside. Do you think the 3 is on the inside or outside?
Outside.
So this impacts it vertically, whereas the plus 2 will impact it horizontally. So will the plus 2 move it to the right or the left? Left, 2 units. So therefore, my vertical asymptote is not at 0 anymore. It's back at -2. So that kind of that graph shifts everything 2 units to the left. And then we have our shapes in opposite quadrants from each other. Question?
No.
Okay.
Jesus.
The next one. A lot of people might ask a question about this, but this isn't too bad because this is the same thing as the cubed root of x. X to the 1/3 and cubed root of x, those are the same thing. And maybe you remember that the parent function looks something like this.
I do remember that.
So what's the transformation going to do to this shape?
It's going to move to the left or to the right 3.
Right 3 units. We look at the next one. That's another reciprocal function, but instead of 1 over x, it's 1 over x squared. What happens if we square something? It makes it, okay, it makes it a parabola if it's x squared in the numerator, but this is the denominator. If we take any number and square it, it's going to become positive. So therefore, the parent function, I'm going to draw in yellow, and then I'm going to erase it. The parent function looks like this. They are both above the x-axis, Okay? So now let's think about the transformation that happens. What is the -3 going to do?
Right 3.
Right 3. And then the negative is on the outside. That creates a vertical flip. The 2 you can ignore. This is a multiplier. It actually ends up stretching the graph, but you don't have to try to show that. So sometimes we want to try to ignore certain parts of the equation, and here you're going to ignore this 2. So the negative will flip it, and the -3 will shift it to the right 3 units. So I'm going right 3. So mine's a little bit easier in that I can show in different colors. You don't have to draw the parent function for your shapes. You can simply draw the end result, but I think for teaching purposes, it's helpful if I show you both.
Yeah.
We move on to the next one. We have this root of 4 minus x plus 1. This is similar to what we saw within your checkpoint. I'm going to go ahead and factor out a negative, and I get a positive x and a -4. I know what the square function looks like. It just heads on off to the right-hand side. What are the transformations going to be in this situation? Left or right?
Right 4.
Yep, I got right 4. Up or down?
Up 1.
Up 1. And then is it going to head off to the right, to the left? Is it going to be flipped vertically, horizontally?
Head off to the right, and it's going to...
Is it going to be flipped? No.
No.
So the negative is on the inside. If it's on the inside, does that impact it horizontally or vertically?
Vertically. No, horizontally.
Horizontally is on the inside. So this is going to flip it horizontally. So instead of heading off to the right, this one will head on off to the left.
It's a lot of stuff to remember.
Can I show you a way so you can tell for sure?
Yeah.
Does everybody agree that this graph, that 6 is not part of the domain? If you were to plug 6 in, you'd get the square root of -2, right?
Oh.
Yeah.
So if you said it did go this way, you'd say that 6 would be part of the domain, yet that tells you that can't be. Okay? So you can think about that. This one I'm going to rewrite it, just use a little trick. I'm going to have negative quantity x minus 2 to the 5th, and then I'm going to put the plus 4 on the other side. So that way you can see that the 4 creates that vertical shift. If it's to the 5th power, it's going to look like a cubic. I will draw that shape. It's going to look very similar to that. The minus 2 will move it right 2. The plus 4 will move it up 4. And the negative on the outside will create a vertical flip. So I've got right 2, up 4, and vertical flip.
Give me that.
I say, give me that.
Try the next one on your own.
Give me that.
We're going to do about 5 more problems together, and then you're going to have the rest of the time to work.
Oh, spaghetti.
Big John, what did you do this weekend?
Nothing much.
Sounds exciting.
Yeah.
You been fun of Big John?
No.
Okay.
Do you farm?
Kinda.
Soybeans and corn? Got beans in yet?
Out.
Did you harvest them yet?
Yeah, yeah,
John,
Sure,
you-
out of the field.
yeah. Yeah.
Okay, the next one here, we have negative 1 over x minus 3 to the 5th power.
Was that funny?
This is something that's kind of important here. Notice that this is a reciprocal function because we have x in the denominator. Notice that the power is odd. So do you think it will look more like the first one or more like the third one? It's going to look like the first one because this is to the first power. This is to the second power. If it's an odd power, it's going to be in these opposite quadrants. Whereas if it's an even power, then it's going to be in adjacent quadrants right next to each other. Okay? So we can see that because this is an odd power, it's going to be in opposite quadrants. So the parent function is going to look, basically like that. Okay? So now we want to create our shift. We see that the minus 3 is going to move it right 3.
3, yeah.
And then what will the negative on the outside do?
It's gonna flip.
Oh.
Create a vertical flip. So instead of being the bottom and the top, it will be in the top and then the bottom. For the next one, we have this 4th root function. Is that going to look more like the square root or the cube root? Square root, because it's an even power, so it's going to look like the square root function. The 2 is kind of messing with me, so what I'm going to do is I'm going to factor the 2 out, and I'm going to get an x plus 3. This is another situation where we're going to ignore the 2. As I factored that, what is my shift?
Left 3.
It is left 3. Very good.
Thank you.
Try the next one on your own.
Oh, what?
Okay, I drew the parent function. I can see that the plus 2 will shift it to the left 2 units, and the negative on the outside will make it flip upside down.
Oh.
Good?
Yes! I did it.
All right, we're going to do 2 more together, and then we'll let you guys work. Flip over to the second page here.
Oh my goodness. Gracious. That is the most graphs I've seen in my entire life.
And what I'd like to do is I'd like to do these two. A lot of times we do all the ones we just talked about, but then we get to y equals 2x minus 3. People are like, I can do everything on the page, but I can't do that one. You can. Don't think about it as a transformation so much as just graphing a line. This is a line with a y-intercept of -3 and a slope of 2. So that's all there is to it. So I threw a couple lines in there to remind you that you know how to graph lines rather quickly. But then I think that this cubed root of x squared, I think that that looks rather challenging for people. And the truth is that this type of function doesn't come up a lot. I have it on here for this purpose. A lot of times people try to memorize what that shape looks like. Other times people try to think about why it looks like the way it does. And I think it's important to understand why it makes the shape that it does. Okay, let's think about the domain. If I plug in, say, -4 into this, can I square -4?
Uh-huh.
Yeah. Can you square +3?
Yep.
Can you square 0?
Yep.
Yeah, so the domain of this is all real numbers, so it's going to be on both sides. Finally, when you square something, it becomes positive, and the cubed root of a positive is still positive. So therefore, the parent function has this shape. It is the bird function. Okay? So it has that shape like a square root function, but they're both above, because when you square it, it becomes positive. So now you know why it makes the shape it does. But I have two transformations, and the first transformation is it moves up 4. And then the negative is on the outside, so it creates a vertical flip. So it'll be like that. I just want you in that moment that if you're on the test, you can't remember what that looks like, that you can think through. Again, you can square any number, so domain on both sides, and then it's going to be positive. Okay. So that's all I have for you. You have the rest of the hour to work on graphing these transformations. Don't be surprised if you get a couple that are questionable to you, but tomorrow we move on to more transformations, just going to talk about a little bit different fashion. Test next week. I have not decided what day next week. But if you ask me right now, I'd say we'd be testing on Tuesday next week.
Okay.
We'll see. If I gave a test on Monday, that you guys wouldn't like that.
Will that be Columbus Day? That's illegal. You can't do a test on Columbus Day.
What are you talking about?
Ben? Columbus?
I agree with Ben.
Thank you, Ben.
I agree with Ben.
Hey Ben, do you think
Ben,
we should celebrate
Just
Columbus Day?
before I get to Zoe's question.